We're going to be talking to you about critical global market challenges having to do with a number of perspectives, namely lead-free regulations, foreign sales, and securing critical technology. So today we're seeing increasing interest from defense, system integrators, and primes in foreign sales to boost their revenues, basically in the face of decreasing US DoD budgets, as the IHS presentation showed this morning. And in particular, there's a trio of factors that are pushing defense spending patterns towards ISR equipment. And that trio of factors is namely rising geopolitical tensions, rapid economic growth from emerging markets, and last but certainly not least, the continuing asymmetric terrorist threat. Now, speaking of ISR equipment, where's Ray? We had heard from Ray this week, actually. There's going to be more closer to home, we're going to be seeing some ISR equipment, some homegrown ISR equipment in the area for the next week or so, up until actually the next 2 weeks, I guess. Now, at the same time, there's been an increase in the growth of lead-free regulations globally. The introduction of the European Union lead-free legislation, which restricted the use of 6 substances in electrical and electronic equipment, which is the triple E in the first acronym there. And unfortunately, lead was one of those substances. And we know what happened is, since then, basically, electronic components have virtually all gone to lead-free. There are very few electronic components available with tin lead terminations. The component manufacturers are just not interested in supporting that approach because most of the product categories from the lead-free legislation have gone to lead-free. Now, let me just... There are still pockets of the industry that are continuing to focus on tin lead. Defense and aerospace is one of them, but there are other ones as well, such as the high-rel server groups. But it's become pretty clear that even for the defense and aerospace embedded system developers, that lead-free is here to stay, and the challenges with lead-free are going to need to be addressed. Now, one of those challenges is, how do you pronounce this second acronym? Some people like to call it, refer to it as RoHS. My personal favorite is RoHS, but we definitely need to stay away from ROS. So since its introduction in 2006, the RoHS, or Restriction of Hazardous Substances Directive, it continues to evolve and actually expand. The expansion has to do with, or evolution and expansion has to do with increasing the number of product categories that are covered, and actually naming the defense and military industry. It was in 2006, it was basically, people said there was an exemption. It was actually not considered as a product category. 2011, it was named as a product category, but the exemption was written. So it's written in law at this point. And then the last pretty big change in 2011 was that there were some specific technology exemptions. The removal of those exemptions was initiated. So, not surprisingly, there's more and more interest in lead-free globally as a result of this, and actually many other countries are implementing their own types of lead-free regulations. So for our industry, one of the key issues is the product integrity risks involved with the so-called tin whisker phenomenon. And let me just, I won't start that yet. The good news is that there's been intensive research applied to this problem that has identified mitigations that will help to mitigate the problem. That's why they're called mitigations. However, before we talk about those, let's talk a little bit about what tin whiskers are, how they grow, and what kind of specific risks they pose. Let's hope this works. Okay, there we go. It's hard to tell. So tin whiskers are basically thin metallic structures that grow out of tin-rich finishes on lead-free component terminations. The growth mechanism behind them is not fully understood, but it is understood that compressive stresses in the plating cause the tin whisker to grow, and there are various scenarios involved with how those compressive stresses arise. And the risks posed by tin whiskers are threefold. First one is kind of obvious. They can they pose a pretty serious shorting concern. There's a possibility of FOD, or foreign object debris, if a tin whisker breaks off and shorts adjacent conductors. And there's also a pretty interesting phenomenon, if you're a geek like me, called conductive plasma generation if one of these tin whiskers shorts at high altitudes. So, it's understandable why tin whiskers are a concern in the DNA industry. Now, much of the focus on tin whiskers has been placed with lead-free. However, some research that Curtiss-Wright has done shows that tin whiskers are actually more predominant on assemblies soldered with tin lead. Now, you still have tin-rich finishes if you're using lead-free components, but soldering with tin lead solder. And in those particular cases, we've seen that the density of tin whiskers is actually higher than with lead-free, and that has to do with the reflow temperatures, pretty different reflow temperatures between tin lead and lead-free. And we've written these results, among others, with tin whisker research up in a technical white paper that we're offering to qualified customers through, and the details are in a news release that we're releasing today. Now, tin whiskers aren't the only issue with lead-free electronics, but they're certainly the most prominent. There are several other issues that need to be looked at and considered. Now, these additional concerns touch on various, a number of different areas of assemblies, if you will, anything from component innards to solder joints to printed circuit boards. So they span the gamut. There's a lot of issues to look at when you're considering lead-free, and lead-free components in particular. And when I say lead-free, I don't just mean lead-free assemblies. I talked about tin lead assemblies earlier. There's also mixed solder assemblies that have to be considered. So it's not really, when I say lead-free, it's not a lead-free assembly issue. It's the use of lead-free components that's the issue, whether you solder it with lead-free solder or tin lead solder, or mixed solders where you take lead-free BGAs and solder them with tin lead and mix two different, pretty different metallurgies together. Now, it seems that we're only beginning to understand the impact of all of this change, these metallurgical change on our electronics, because the potential legal ramifications are just starting to emerge. And there's basically been a suit recently in California against Apple on its 15 and 17-inch 2011 model MacBook Pros, where the plaintiffs claim to have suffered from, and I'll quote here, random bouts of graphical distortion, system instability, and system failures, end quote. And the complaint specifically blames the solder. So they said that the lead-free solder tends to develop microscopic tin whiskers, which cause short-circuiting and other problems within electronic devices, exactly what I was talking about earlier. And last but certainly not least, the suit claims that Apple did this basically to homogenize their products because they're building worldwide, and they definitely have to sell into the EU with the RoHS legislation. So they're basically building everything as lead-free. And as a result, these US customers are not happy with the issues that they're seeing. Now, given the less critical nature of laptop electronics compared to our industry, this is a clear warning alarm about the risks of lead-free. So I mentioned previously that substantial tin whiskers has been performed, and we have data and mitigations to show to our customers. Now, we're not claiming we've solved the tin whisker growth problem. That's a much bigger issue. But we have identified mitigations that have tamed the tin whisker issue. And as I mentioned, we're sharing that with our customers. The kind of deep science work that's involved in solving the tin whisker growth problem is being done. It hasn't been completed. And a lot of that work is being channeled through a group called PERM. The P stands for PB, for lead, lead-free electronics risk mitigation or management. And the PERM group has been in place for well over a decade. It's really the main body that represents the A&D industry for lead-free issues. All of the primes are there. A lot of the government agencies are there. We're there as a COTS supplier. And the PERM group has issued a number of documents, a couple of which have identified most, if not all, of the main lead-free risks. We've taken that and put that into this table and basically used a similar approach to what I described for tin whiskers, where we've identified from the deep science work that's happening on all of these different issues, we've identified mitigations, tested them in realistic scenarios, and made sure that they work in the deployed A&D systems that we're going into. And I would say again, once again, we're not claiming to have solved all these issues. There's a lot of other deep science work that has happened and continues to happen. But we have employed mitigations, and we're at the point now where we've done enough work. We've been working on this since 2006, and we feel we've done enough work that we're confidently offering lead-free products to our A&D customers, for deployment in deployed applications. So in summary, our industry needs to understand and mitigate the numerous risks involved with lead-free component use. And with a special emphasis on tin whiskers. And the mitigations that we identify, as I mentioned, they need to be, not only, they can't just work in a lab environment. You have to deploy them in realistic scenarios that are representative of the A&D systems that we're selling into. And with these goals in mind, Curtiss-Wright is announcing that we're going to be forming a lead-free working group within the VITA Standards Organization in 2015 to lead the charge for COTS suppliers to identify methodologies that we can use to address these risks and make sure that the products that we sell into the A&D systems continue to be reliable. And I'll hand it off to Steve at this point.
Thanks, Ivan. See if I got So I'm going to talk about another global market challenge, and that's trusted computing. There's a lot of euphemisms that go around, right? But this is basically protecting and securing your technology as it gets deployed. Right? The government is spending billions of dollars in developing these systems, and as they get deployed, the risk is there that these systems will or these assets will fall into the hands of adversarial nations or people, and they will try to compromise them, reverse engineer them, and the technological advantage goes away, right? So, and this becomes even more true now as defense budgets are shrinking, and now companies, the Defense Department and the primes are looking to sell more globally, right? Because they want to make their return on their investments, and now you've got FMS is cropping up, and what that means is it just means you've got more product out there, and the more product out there, then the higher the risk that somebody's going to get a hold of one that you don't want them to get a hold of. And so this becomes a challenge for the defense industry, and something that is really being pushed down the food chain at all levels. And I'm sure, for a case study, I'm sure we all are familiar with what happened to the Navy EP-3 back in 2001. It got into an accident, had to crash land in China, and nobody was harmed. The crew was able to land the plane, and they were able to, after a short delay, come home safely, but the Chinese did not return the plane.
The Chinese fighter pilot was harmed.
Okay, maybe the Chinese. Yeah. And the plane eventually came back as a bucket of bolts, right? So they had taken the plane apart and reverse engineered it. Now you can't stop that from happening. You can't stop something from getting lost, falling into the wrong hands. What you can do is work to protect those technologies to make it harder for companies or for adversaries to gain access to that critical technology that you've worked so hard to develop and spent lots of money to develop. And I think, and we're seeing this being pushed down, like I said, all the way down the food chain, and it's coming down into the COTS companies, right? As defense budgets shrink, companies no longer have the money to divine to use a British term, to develop these bespoke systems, right? These systems that are kind of one-off just for that particular program, and spend hundreds of thousands, millions of dollars, whatever it is, on developing this security solution, especially when the market is moving towards COTS. They're trying to, for cost reasons, COTS is becoming more and more of a player in the overall defense industry, and so they're driving security down to the COTS level as well. And I believe there are things that we as COTS vendors and COTS industry can do to protect the hardware, to protect the critical technologies that we have. It doesn't mean we're going to solve everything. It doesn't mean that that in the end we're providing the solution, because that really is the job of the primes. But there are capabilities and things we can do at the board hardware level and even at the software level to protect that technology that eventually will end up on our products. Even if we have to customize our products, it's the difference between the small dollar sign and the big dollar sign, right? We may have to customize a COTS module for some amount of money. That's a small dollar sign. But if a prime like a Lockheed Martin or Northrop Grumman or a Raytheon has to develop a custom solution, that's a big dollar sign. It's an order of magnitude more expensive for them to go ahead and develop a custom solution than to leverage COTS if that's possible. So I think of this a little bit as like peeling back an onion, right? So the whole idea of security and protecting things is there's no one solution. There's no magic bullet. If you just do this, you've got the answer, right? It depends on the program. It depends. There's a whole way that the primes look at this, but it really is, you want to think of it as you need multiple pieces protecting each other, because, like I said, no one piece solves things. You can't just put an encryption algorithm in your FPGA and say that that's going to solve everything. But you want to have implementation techniques in your hardware to be able to solve things you can do at the hardware level. You want to have pieces of software, pieces of HDL on your board that can then check each other and counter-check each other, so you have checks and balances. And if you can, you want to have a protected volume around the outside, a kind of a physical wrapper around the outside to protect these things. So these things all are checks and balances against one another. So the more pieces, the more layers you add. And again, these are things that COTS vendors can do. The more layers you add, you provide that capability that the primes and the integrators can take advantage of and make your product more secure. So one example is at the protected volume level, right? So I can't go into a lot of detail, but you think about what COTS companies are good at now, right? We already have volumes around our products, right? We have conduction-cooled products that have heat frames, that have covers on them. So we already have physical enclosures around our modules to prevent easy access to components for good reasons, right? We need them for thermal reasons. We need them for two-level maintenance and things like that. So really, it's taking that and now determining ways that you can leverage that, and then provide mechanisms, technologies that would prevent somebody from easily removing that cover, that would prevent somebody from using electronic means to gain access to your card. So there are things that you can do. And there's challenges as well, because a lot of the things that you can do affect the thermal performance of your card. And so there's a trade-off and a balance and things you've got to do from that perspective to allow yourself to have protection mechanisms but still meet the environmental requirements of your solution that your product's going to go into. So that's just one example of things that a COTS company can do. But I think it also goes beyond the COTS industry, right? So I think the people in this room largely get it, right? We know what we're trying to do. We know the challenges. We know the risks out there. The government, they get it. They get it at a different level, though, right? They get it as well, right? They're the ones that are driving us to do these things, but they're thinking at a much higher level. And sometimes, the government and the COTS industry are like this, right? We don't really talk to one another. And it's amazing when I've gone and actually talked to a government customer, they said, "Oh, you guys, COTS? What's that?" Right? They don't really know, right? Because they're used to talking about these big systems and they don't get down to that level of detail. So, but we need to have interaction with people in government, educate them on what COTS can do, educate them on things you can do at the COTS level to protect this technology, as well as having the primes involved. And then you need to get into academia involved, right? There's a lot of good work going out there, either in small little research companies or or in universities that you can leverage to solve parts of these problems. So it really is getting the whole community together and having everybody kind of talk to one another. And there are conferences and things like that where people do get together periodically. I think there needs to be more of that. So, and I'll blame John for his Chinese takeout slide. Somebody else looked at this slide and they go, "I don't get it. I don't get it." But anyway, so really the takeaway is that security, trusted computing, whatever you want to call it, is real. It is being driven down into industry today. They used to get waivers. Those are going away, right? The companies are no longer getting waivers on new programs. It's becoming more of an upfront issue, and at least at some level, we can solve it, I think, in the COTS industry, right? We've got certainly a lot of people that are smart people that can work on this problem to come up with solutions. So that's it. So Ivan and I will take any questions you might have.